Mercury's apparent magnitude is calculated to vary between -2.48, brighter than Sirius, around superior conjunction, and +7.25, below the limit of naked eye visibility, around inferior conjunction. The mean apparent magnitude is 0.23, while the standard deviation of 1.78 is the largest of any planet. The mean apparent magnitude at superior conjunction is -1.89, while that at inferior conjunction is +5.93. Observation of Mercury is complicated by its proximity to the Sun, as it is lost in the Sun's glare for much of the time. Mercury can be observed for only a brief period during either morning or evening twilight. But in some cases Mercury can better be observed in daylight with a telescope when the position is known, because it is higher in the sky and less atmospheric effects affect the view of the planet. When proper safety precautions are taken to prevent inadvertently pointing the telescope at the Sun, and thus blinding the user, Mercury can be viewed as close as 4 degrees to the Sun when near superior conjunction. When it is almost at its brightest, Mercury can, like several other planets and the brightest stars, be seen during a total solar eclipse. Like the Moon and Venus, Mercury exhibits phases as seen from Earth. It is new at inferior conjunction and full at superior conjunction. The planet is rendered invisible from Earth on both of these occasions because of its being obscured by the Sun. Except its new phase during a transit, Mercury is technically brightest as seen from Earth when it is at a full phase. Although Mercury is farthest from Earth when it is full, the greater illuminated area that is visible and the opposition brightness surge more than compensates for the distance. The opposite is true for Venus, which appears brightest when it is a crescent, because it is much closer to Earth than when gibbous. Nonetheless, the brightest, full phase appearance of Mercury is an essentially impossible time for practical observation. Because of the extreme proximity of the Sun, Mercury is best observed at the first and last quarter. Although they are phases of lesser brightness, the first and last quarter phases occur at greatest elongation east and west of the Sun, respectively. At both of these times Mercury's separation from the Sun ranges anywhere from 17.9 degrees at perihelion to 27.8 degrees at aphelion. At greatest western elongation, Mercury rises at its earliest before sunrise, and at greatest eastern elongation, it sets at its latest after sunset. Mercury is more often and easily visible from the southern hemisphere than from the northern. This is because Mercury's maximum western elongation occurs only during early autumn in the southern hemisphere, whereas its greatest eastern elongation happens only during late winter in the southern hemisphere. In both of these cases, the angle at which the planet's orbit intersects the horizon is maximized, allowing it to rise several hours before sunrise in the former instance and not set until several hours after sundown in the latter. From southern mid-latitudes, such as Argentina and South Africa, an alternate method for viewing Mercury involves observing the planet during daylight hours when conditions are clear, ideally when it is at its greatest elongation. This allows the planet to be found easily, even when using telescopes with 8 cm 3.1 in apertures. However, great care must be taken to obstruct the Sun from sight because of the extreme risk for eye damage. This method bypasses the limitation of twilight observing when the ecliptic is located at a low elevation, e.g., on autumn evenings. Quote, ground-based telescope observations of Mercury reveal only an illuminated partial disk with limited detail. The first of 2 spacecraft to visit the planet was Mariner 10, which mapped about 45% of its surface from 1974 to 1975. The second is the Messenger spacecraft, which after 3 Mercury flybys between 2008 and 2009, attained orbit around Mercury on March 17, 2011. To study and map the rest of the planet, the Hubble Space Telescope cannot observe Mercury at all, due to safety procedures that prevent its pointing too close to the Sun. Because the shift of 0.15 revolutions in a year makes up a 7-year cycle, 0.15 times 7 approximately equals 1. 0. In the 7th year Mercury follows almost exactly earlier by 7 days. The sequence of phenomena it showed 7 years before,